Hi, I'm Katarina.
Hi, I'm Lena.
We are both graduate students at the Harvard-MIT Health Science and Technology program.
And we both do research here in the Koch Institute in the SEMA lab.
I work on designing implants to help ovarian cancer patients receive their treatment. Specifically, I use origami to build these tools, these implants.
And I've been watching Katarina's project for years, really admiring these beautiful origami implants that she's creating to help cancer patients. And so when she came to me asking to help take pictures of these implants to help communicate her science, I was really excited to help out.
So the image behind us is a picture taken of a prototype that I made in lab for a project that has to do with designing an implant to treat patients with ovarian cancer. Specifically, what happens in this disease is that patients get cancer spread all over their belly, their abdomen, and it's common in ovarian cancer, but also in other kinds of cancers that have a similar location, and they have to get chemotherapy. So what we were trying to do is come up with a way to get as much drug as possible and as much a surface area as is possible in the belly, in that space, but passing it through really tiny tools, because we don't want the patient to have to go through a very invasive surgery and open them up again to put a huge kind of device in there. And that's where origami comes in, because it's an art of folding things down and then opening them up in a different shape. What you see is a proof of concept prototype of a material we developed in the SEMA lab for this implant, and a proof of concept origami fold or tessellation that we picked.
Taking a 2D image is hard because they're either completely white or they're transparent, and it's hard to really communicate the texture behind it. So that's what we were trying to do in taking these images, and so we experimented with a bunch of different setups. We actually used origami paper to bring out the color. So we used different colors of origami paper to in the background behind these implants with light shining from the back. And that gave the implants these colors, and then through different light setups we could really get interesting shadows that even in a 2D image you can get a sense of the texture and the elevation behind the implant.
This particular origami fold is known as like a V-pleat version of the Miura fold. The Miura fold is a really cool origami fold which you can find in maps, you can find it in satellites, and it allows you to fold something down to a really tiny shape and then open it up in 2 dimensions.
So just taking a step back from the science itself, I think it's really amazing to realize that it's this really ancient art form of origami that's now being used in this really high-tech world of medical engineering to create better therapies for cancer patients.